All right. Okay. Just to recap, all right. Just to recap whatever that we have learned last week regarding dot product. Okay. So last week we talked about dot product. So we said that dot product is is a type of vector multiplication. All right. And we have another name which is what we call scalar product, because basically when we do the multiplication, all right, our product is a real number. So that's why we call it scalar product, or it's a dot product because of the notation of the dot in between. All right. So we have looked at how we actually do the dot product using components. All right. So basically, most of the time we are actually dealing with components of vectors. Okay, when we add, subtract, multiply, etc. Okay, so this is how we multiply. All right, the dot product. Okay, from components. So the answer is actually it's a real number. So we have actually looked at some of the examples. And then we also talk about the definition, okay, the definition of the the definition of the dot product itself, okay, and involved with angle, okay, because the fact that for dot product, in terms of geometric interpretation, okay, in terms of geometric interpretation, where you have like angle here, okay, so you have actually uh, product or dot product, or another word, a multiplication of two vector. Basically you have these two vectors where the initial value or initial point for both vector coincide, okay, so it has an angle in between. Okay, so that's why you have this type of definition, all right, for the dot product that involve with an angle. Okay, so basically, if the question asks us to find angle, all right, angle between two vectors, so we are actually using this type of definition or this type of theorem, okay, for the dot product. All right. So basically, for dot product, okay, we'll be actually also using a lot of this, when it comes to calculation, especially for the angle, Every time there's an angle involved, okay, question asking you for finding angle between two vectors is actually involved with the dot product. Okay. Later on, you will see cross product also. You have a definition involved with angle, but for cross product, okay, normally we will not ask about like angle in between vectors. Okay, angle basically is all about the dot product. Okay, so don't get confused later on. Okay, and then we talk about also one important theorem last week regarding what we call the orthogonal vectors. Okay, orthogonal vectors is where we have two vectors perpendicular to each other, and it will make an angle of 90 degrees. All right, so you have like this. Okay, so basically that's a important concept. All right, for orthogonal vectors or vectors perpendicular to each other, where the angle is actually equals to 90 degrees. Angle between them equals 90 degrees. So basically, when you are asked to verify whether two vectors are orthogonal, you have to actually show that the dot product equals to 0. Okay, all right, so this is very important. All right, and then we also look at some of the examples last week. All right, this is verifying. This is a question on to verify whether two vectors are orthogonal, all right, or not. And then we also have what we call concept of direction angles and direction cosine. Okay, so basically what we are saying is that, all right, if we are dealing with a three-dimensional, okay, three-dimensional uh, vectors, all right, or three-dimensional coordinate system, where we are looking at like one vector r here. So basically this one vector r has what we call three direction cosine or three direction angles, and that direction angles basically is the angle which is formed by the given vector, all right, formed by this vector, all right, to all these three different axes, okay, x, y, and z. Okay, so you have your alpha, beta, gamma. So these are all what we call direction angles, and you have actually some sort like a formula, okay, to find what we call the direction cosines or direction angles. So that's what we have actually covered for last week. Okay, I hope there's no question regarding the dot product. So let's move on, or let's continue with cross product today. Okay, so basically this is the last section, all right, for vectors. So dot cross product, basically this is also another type. Okay, so this is also another type of vector multiplication. Okay, This is also another type of vector multiplication. All right, so you have dot product, you also have cross product. However, the cross product is only for three-dimensional, okay, three-dimensional space. So this is only for three-dimensional space, okay. All right, so that means, okay, if you are dealing with two-dimensional space, you don't talk about a cross product. So cross product basically is only for three-dimensional space. All right. Okay, and another name for cross product is actually is what they call also vector product. So that's another name also. Okay, for cross product, they call it vector product. Why is it called vector product? Because cross product, the product itself is actually is a vector. Okay, so the difference between dot product, all right, dot product and cross product is that dot product, the product is a number, a scalar number, all right, whereas cross product, the product is a vector. Okay, so when it comes to a vector, that means when you want to find the cross product, that is what they call a geometric illustration. Okay, because the product is a vector, so that means that vector has a direction. So which means that the product is a vector with a direction. Okay, and the direction of the vector, all right, if you recall, because you have done this before, if you recall, okay, the direction of the product for the cross product is actually is what they call like a normal vector. It is actually is a vector pointing, okay, pointing either upward or downward. Okay, all right. So in other words, if let's say for example in terms of geometric illustration, okay, if you have like again when it comes to product of vector multiplication, is understood like the dot product also. You will have a two vector uh, where the initial point is actually coincide. Okay, the initial point coincide. So when it comes to cross product, when we multiply these two vector, because the product is a vector, so that vector is actually is a vector pointing, okay, pointing either upward or pointing downward. Okay, so it depends on what cross what. Okay, but basically if I'm saying u, all right, vector u cross vector v, so this is actually what we call u cross vector v. So basically the notation for excuse me, the notation for cross product is actually is a, like x, or we call it cross. So we call it like a u cross v. Okay, whereas if it is a dot product, you have a dot in between. So if it is a cross product, it's a cross in between. Okay, like a multiplication x, like that. Okay, so that is a notation for cross product. Okay, so cross product, because the product is actually is a vector, so that vector is actually is a vector pointing upward or downward, in which the angle, all right, the angle between vector u and vector v towards this cross product, it makes a 90-degree angle. Okay, it makes a 90-degree angle, all right, like that. Okay, so sometimes you may see like in other books they call it like a normal vector. Okay, a normal vector. In fact, last time, if you recall, if you have done this, all right, before, if you recall, that is what they call a thumb rule, right, a right hand rule. Okay, for the cross product, where the u cross v actually is a vector pointing right in the direction of your thumb. Okay, pointing. Okay, I don't have the okay, because we are not face to face, but if you can see, all right, if you can see from the screen, all right, so basically, can you see? If you see that this is, I have a red pen here. Okay, this is like, for example, vector u, and then another one, maybe another one is I have another vector here. Okay, I don't know whether you can see. Okay, but basically if you have like can you all see? Not really clear, isn't it? Okay, but what we are saying is that in terms of geometric illustration for the cross product, okay, you have like, let's say this is a vector u, another one is vector v. All right. So if I put my right hand, okay, onto vector u, so the cross product means I'm going to curl my hand. So my thumb is actually is pointing towards the cross product. Okay, the product. Okay, for this multiplication, this product multiplication. Okay, so something like that. I have actually a diagram later to show you. Okay. All right. Okay. Um, Similar to dot product also, when we want to find the cross product, okay, we are also dealing with component, okay, components of vector. Now there is a definition. Okay, now if you look at this, if you look at the definition for the cross product from the component, okay, what is this actually? If you recall, okay, this is actually is finding what? Last time we have done this. This is actually is similar to actually finding a determinant. Okay, so that means finding cross product is actually is the same concept as finding determinant of your 3 by 3 matrix. Okay, it's actually is similar. Okay, it's similar. Remember this type of notation? You have a notation of like finding determinant like a bar like this. Okay, so basically is same concept as finding determinant. So that is actually is to find cross product. All right, cross product for two vectors. Okay, from a two vectors. So if let's say you have this vector u with this component. All right, u1, u2, u3. You have another vector v with this component v1, v2, v3. And of course, they are in three-dimensional space because we said that cross product only happens in three-dimensional space, not two-dimensional space. All right, so then the cross product U cross V is the vector defined by, okay, so what you need to do is you need to set up like a determinant 3 by 3 where the first, all right, the first row here is your vector ijk. Okay, you put your ijk in the first row. Second row, you will put the components for your vector u because what you have is u cross v. So when it is u cross v, so the second component would be actually referring to components for vector u. And then the last row would actually be the components for vector v. So when you want to find cross product, basically you are finding determinant. Okay, similar concept of finding determinant. It's just that your first row is your ijk. Okay, your ijk. That means it's your unit vector ijk. All right. Okay, so then it's like you okay, what you have here is okay, there's a typo here. There's a typo here. Okay, this is actually supposed to be minus. Okay, there's a minus there. Okay, so it will be like remember last time when we did a determinant where to find for the determinant for the I, all right, you just cover this column I, okay, you cover column I, okay, so that means you cover column I, all right, so that means you cover column I and you cover the first row, so then you have your this component here, or in terms of matrix last time is the entries. Okay, minor is a minor, remember, minor of 3 by 3 matrix. So that is your u2, u3, v2, v3 is here. Okay, all right, of I, and then this is minus. Okay, and then for the j, all right, for the j vector, all right, you cover, all right, you cover first row. Also, because of j, you cover the first row, and then you cover second column for the j. Okay, so you have your u1, u3, v1, v3 here. Okay, so this it is actually is a determinant of a minor, right, for your vector j, and then plus. Okay, the last one is for the k, so that means for k vector, you cover also first row and then third column for k. So then you have this. This is the minor last time. So you have u1, u2, v1, v. All right, V1, V2. Okay, why is it that this is minus in between here? You have a positive I minus J plus K. Because you remember last time when we did a matrix, all right, to find determinant of 3 by 3 matrix, there's a cofactor. You have a factor of -1 to power. Okay, -1 to power. So basically last time, if you have a 3 by 3 determinant, remember there's a sign. Basically, you have a sign plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, and this sign, remember you got it from this formula factor of -1 to power I plus J when we did our matrix, right, in our first chapter. So that's why, all right, the second here, okay, first row, second column is a minus because you have your -1 to power, all right, 1 plus 2. So it's 3. So up here, all right, the power is actually is odd. So that's why you have -1 to power 3 is a minus. So basically you have this sign, plus, minus, plus, okay, accordingly. So that's why you have this sign, plus positive I minus J plus K. Okay, so you have that. Okay, so basically it's actually a similar concept as your determinant last time. All right, so this is how we actually find cross product, okay, from components. So you have this, okay, and then of course there's a note just to say that the cross product is only defined in 3-dimensional space, okay, whereas the dot product is defined for both 2-dimensional and also 3-dimensional space. And then cross product of two vectors is a vector. Okay, so this is again important note. All right, that cross product is only for 3-dimensional space, and that the product itself is actually is a vector. So that's why sometimes it is called cross product or vector product. Okay, and again the vector, because the answer, the product is a vector, so that vector has a direction, and the direction of that vector is actually is pointing towards what we call the normal. Is actually like what they call normal vector, pointing upward or pointing downward depending on, okay, whether you are talking about U cross V or V cross U. Yeah. Okay, let's do this example so that it makes sense to you. All right, let's do one example. Okay, let's say you want to find compute this cross product vector U cross vector V. Okay, given that U is 1, 2, 3 and V is 4, 5, 6. Okay, so again, to find U cross V from component, first of all, you need to like sort of like set up, okay, set up like your determinant 3 by 3, okay, in which the first row is your vector ijk, your unit vector ijk. That's the first row, okay, and then second row it will be component for vector U. Okay, if let's say we say that it is if we say V cross U, then that means the second component, second row, sorry, second row, it will be component for V. The last row will be component for the U. So it depends on what cross what. Okay. So in this case, for this example, it will be U cross V. So the second row you will put your U component. Okay, vector U component. So that means it's 1, 2, 3. That's the second row. Okay, first row is always your ijk vector. Okay, your unit vector ijk. So second row is 1, 2, 3. So the last row in this case is 4, 5, 6. Okay, so you are going to find determinant. Okay, like the finding determinant of 3 by 3. Okay, and I would suggest you put like this first. Positive I minus and then J plus K. Okay, you write like that first. Okay. All right. Okay, let me just, so that it will be correct, plus minus. Okay, because this thing, finding determinant here, if you, there's always a tendency of making mistake in terms of plus minus. So you have to be very careful. Okay, similar to last time when you find determinant of your matrix, 3 by 3 matrix. So there's always like a discrepancy in terms of plus minus sign. So you have to be very careful. Okay, so I would suggest perhaps you write like this one first. Okay, and then what you need to do, then only you put your component for your 2 by 2 matrix, determinant for 2 by 2 matrix, or your minor 2 by 2. So that means for the I, okay, so you just need to cover, you just cover the first column like this. And then you just look at this, okay, cover this, okay, cover the first column, look at this number. So that's the one where you put your minor, okay, determinant for minor matrix, which is 2, 3, 5, 6. And then for the J, you just cover here, the middle column. So look at your 1, 3, 4, 6. Okay, so 1, 3, 4, 6. Okay, and then the last one, you cover the last column. So you have your 1, 2, 4, 5. So 1, 2, 4, 5. Okay. All right. Then make sure you find, this is now finding determinant of 2 by 2. So don't make mistake. It will always be main diagonal. You multiply main diagonal. All right. And then minus the product of these two number. Okay. All right. Okay. In the exam, all right, this step, okay, writing this step, there's a method mark for here. Okay. There's a method mark. So you must show this because there's a mark for this method. Okay, because the method is actually similar to finding a 2 by 2 determinant. So you must show this. So when you show, you must make sure you write it correctly. Okay, because there's a method for that. There's a mark for that. Okay, all right. Then only make sure you compute correctly. Okay, let me just write this step by step first. So make sure you multiply the main diagonal and then subtract 3 times 5. This is for the I, vector I. And then plus, and this is minus, okay, and then followed by minus. Okay, and then you have your 1 times 6 minus 3 times 4. This is for the J. And then plus, okay, and then you have your 1 times 5 minus 4 times 2. This is for the K. Okay, so make sure, all right, do this correctly, okay, for 2 by 2 determinant. Okay, so then only now you start multiplying. All right. Okay, so then you have your 12 minus 15. Make sure it's correct, plus minus. Okay, so 12 minus 15. So that will be minus 3i. Okay. All right. Followed by minus. Okay. Write your minus first. Okay. Write out your minus first. Okay. And then maybe you might want to put a bracket. Okay. And then you have your 6 minus 12. Okay. So 6 minus 12, that is minus 6. Okay. Later you will see you have a positive there. Okay, and then followed by plus. Okay, and then you have your 5 minus 8. So then you put your minus 3. Okay, then only finally you write it correctly. So it will be minus 3i plus 6j minus 3k. Or if you want to write in terms of this type of component, also can. So up to you. This is the last step is just optional. Okay, the last step is just optional. Until here, all right, you can actually get a full mark if it is correct. Okay, until here it will be a full mark if it's correct. So last step is just optional. So you don't need to write if you don't want to. Okay. All right. So any question? Any question from anyone? Okay. So
No,
this is
madam.
how, all right. Okay. So this is how we do our cross product. Okay. So compared to dot product last time, dot product is quite straightforward. In fact, dot product is easier because you just multiply, plus, multiply like that. And then you finally it's just a scalar number. So dot product is much easier as compared to cross product. So cross product, is not to say it's difficult, but it's a bit tedious in the sense that you must make sure that you write it correctly, okay, the method, all right, and then make sure you compute correctly also plus minus, because there's always a tendency of making mistake, especially when it comes to the plus minus of the determinant. Okay, all right. Okay, and then you have also algebraic properties for the cross product. Okay, all this you can actually go through. You can look at from your book. Okay, everything is there. This is just a properties. All right. The first property is actually some sort like important also. Okay, u cross v equals to minus v cross u. Okay, that means u cross v is actually equals to minus v cross u. That means u cross v is actually the vector, the product is pointing upward. So if it is minus v cross u, if you do like v cross u, that means the your thumb is actually pointing downward. So that's why it is a minus. Okay, it's a minus. Later I'll show you the diagram. Okay. Okay, you have okay, there's another geometric properties of the cross product that which is also important to note. Okay, the one in the box. All right, which says that okay, if you have like u dot u cross v equals 0 if u cross v is orthogonal to u. V dot u cross v equals 0 if u cross v is orthogonal to v. Okay, this is also another important concept, okay, when it comes to orthogonal vectors. Okay, because it goes back to the understanding of the dot product last time. Okay, because you remember last time previously when we talk about dot product, if you say that u dot v equals to 0, that means this u and v, all right, u and v are orthogonal vectors. Okay, so if you have a dot product equals 0, all right, dot product equals 0, then we said that those two vectors are orthogonal. Okay, so comes back to here, the fact that u cross v is also a vector. Okay, u cross v is also a vector. So when it is a vector, you can actually dot with another vector u. It makes sense, all right? Because this is vector, so this is vector. So when you dot, and if you get 0, that means, all right, that means u and v also is orthogonal. The cross product, the one that is pointing upward, is actually orthogonal to u. Okay, vector u. And similarly, the cross product also orthogonal to v, which means that it is actually is coming back to the diagram just now I showed you, like where you have like one vector u, and then you have another vector v, and then you have a vector pointing upward. This is u cross v. All right. From this explanation here in the box, okay, what we are saying is that basically, all right, this vector u here, is actually making 90 degrees to this cross product. Similarly, this vector v also, all right, making 90 degrees with this vector. So obviously you will have, this is like this is 90 degrees, this is also like 90 degrees here. Okay, so that means this vector u is orthogonal to this cross product u cross v. This vector v also is orthogonal to this cross product. All right, if you will see that when you dot this vector u and you dot this cross product, you get 0. And similarly, this vector v, you dot with this product here, the cross product here, then you get 0. So that means they are orthogonal. Okay, they are orthogonal. Okay, so then you have this theorem. For any vectors u and v in R power 3, that means it's a three-dimensional space. Okay, this is what it means, three-dimensional space. For any vectors u and v in three-dimensional space, the cross product is orthogonal to both u and v. So this is actually is what I'm explaining here. Okay, that this u cross v is orthogonal to u as well as orthogonal to vector v. Okay, this is the one. This is the diagram, which is what they call the right hand rule. Okay, you have a right hand rule. So in this case, it's a vector A here. This is vector B. All right. Similar to like just now, U and V. Okay. So this is one vector A, this one vector B. So basically using what they call the right hand rule, you put your hand on vector A, and then when you say you cross, all right, A cross B, that means you curl your fingers, all right, from A to B, and then your thumb here is pointing upward to the direction of the cross product. That is the direction of that cross product, A cross B. And if it is like this, you are going downward. Okay, if you say B cross A, that means you are actually putting your hand onto your vector B, and then you curl towards A, so that the thumb will actually pointing downward. So that's where you have your negative just now. Okay, B cross A is actually towards downward. So that's why from this, okay, concept is where you have your A cross B, all right, equals to negative of B cross A. Okay, from both diagrams. So basically this is the diagram of what we call the right hand rule, okay, for the cross product. Okay, and you can see that, all right, there, this is where we say the 90 degrees here. If you can see that this vector A here makes 90 degrees to this cross product. All right, B also, vector B also, all right, it makes 90 degrees to A cross B. Okay, all right, so this is the right hand rule diagram. Okay, let's continue do the example here. Okay, using the same vector u and v in the previous example, find v cross u. Okay, basically this example is just to some sort like to prove, okay, to prove to you this concept here. Okay, to prove to you this concept here, that a cross b equals to negative b cross a. Okay, this is actually is from just now the theorem here. Okay, that u cross v, vector u cross v equals to negative of v cross u. Okay, so then we have this example here. All right, that using the same vector u and v in the previous example, find v cross u. Okay, the example just now. Okay, the previous example, this one. Okay, u is 1, 2, 3, v is 4, 5, 6. Okay, 1, 2, 3 and 4, 5, 6. That is the vector. Okay, so basically, let me just write again. Okay, vector u is 1, 2, 3, and vector v is 4, 5, 6. Okay, so now the question asks us to find v cross u. Okay, this is just to prove, to show you how do you to show you that the theorem actually makes sense. It's actually it's a correct statement. Okay, let's do this v cross w. Sorry, v cross u. So if we say v cross u, that means again, all right, the first row is always our ijk. Okay, second row, this time the component is for component v. That means 4, 5, 6. Okay, and then the last row will be the component for u, 1, 2, 3. Okay, and then as I mentioned earlier, I would suggest that you write like this, the I minus and then j plus and then k. Right, like that one first. Okay, and then, okay, for the first one, you just cover your I column. Okay, so then you have your 5, 6 to 3. 5, 6 to 3. And then for the second one, for the J, you cover, all right, J column, cover the J column. So then it will be your minor would be your 4613, 4613. And then for the last one, you just cover your K column. So then it will be your 4512. Okay, and then you compute correctly your determinant. All right. Basically, you multiply your main diagonal first. 5 times 3 minus 6 times 2. This is for the I. And then followed by minus. And then 3 times 4, main diagonal, minus 1 times 6 for the J. And then plus. And then main diagonal, you multiply 4 times 2 minus 1 times 5. This is for the K. Okay, all right. So then now you start, all right, multiplying, compute. So 15 minus 12, so that is 3i. Okay, minus, followed by minus. Okay, 12 minus 6, so that is positive 6, so 6j. Okay, plus, and then 8 minus 5, so that is positive 3, so it will be 3j. Or in other words, if, again, as I said, if it is everything correct until here, you get a correct answer, correct full mark for that. I just want to write the last one. This is optional. Okay. And if you look at the previous answer just now, from the previous answer, what we got just now, minus 3, 6 minus 3. Okay, minus 3, 6 minus 3. So previously, okay, from the previous example, all right, from the previous example, our U cross V previous example, we got minus 3, 6 minus 3. So if you compare with our answer for V cross U, you see, all right? So isn't that shows you that this is actually U cross V is the same as negative of V cross U. Okay, so just want to show you that, okay, for this example. Okay, so this is actually is one of the also the important theorem, okay, when it comes to cross product. All right. Okay. You also have another theorem here, because there's also angle between U and V. All right, between your vector U and vector V. Okay, but because this is actually is in a three-dimensional space, so there is actually is a diagram. Okay, there's a diagram. All right, for the three-dimensional space for this type of cross product, because the diagram is basically you have a whole diagram like this. Okay, when it comes to cross product, cross product, you have all this diagram like this one, as well as the one pointing upward, okay, for the cross product. Okay, so in that sense, there's a theorem also. All right, some sort like a definition. All right, okay, it's a theorem which says that if theta is the angle between vector U and vector V, then, okay, the magnitude, okay, this is talking about the magnitude, okay, the magnitude of the cross product. Okay, the magnitude, so the magnitude of the cross product is given by the magnitude of U times magnitude of V times sine theta. This is actually is one theorem talking about magnitude of the cross product, because cross product is a vector. Okay, so when it is a vector, right, it also has a magnitude. Okay, so it also has a magnitude. So the definition for the magnitude for this theorem, it says that the magnitude of this U cross V, all right, is equals to magnitude of U times magnitude of V times sine theta. So in this case, if let's say question asks for magnitude, okay, of the cross product, and theta is also given, all right, then you can actually use this theorem, all right, to find the magnitude of the cross product. Okay, this type of theorem will only applicable, all right, for the question whereby they straight away give you what is the magnitude of u, what is the magnitude of v, and then what is the angle between u and v. So when all these three information are given, then only if question asks you for magnitude, all right, of u cross v, then we can actually use this theorem. Okay, however, this type of actually question is actually not really that popular. Okay, in the sense that most of the time when question asks for magnitude of a cross product, is actually they are given you a component. They give you a component straight away for vector u and v. So then you just find the cross product using this type of method, and then just compute the magnitude. Remember, magnitude, when you have this vector, when you find the magnitude, you just need to square, all right, square root of this square plus this square plus this square. That is actually is a formula to find the magnitude. Okay, all right, and then you have okay, this is another definition. This is another important definition or theorem in terms of the cross product equals 0, that two non-zero vectors u and v in three-dimensional space, vector u and v are parallel. Okay, so the word here is parallel if and only if u cross v equal 0. Okay, so if u cross v equals 0, two vectors are parallel. Okay, all right, if u cross v, all right, u cross v equals 0, u and v are said to be parallel. If u dot v equals 0, those two vectors are said to be orthogonal. Okay, so don't get confused. So sometimes question may say that determine whether these two vectors are parallel. So when the word is parallel, okay, that means this is what you need to show, that u cross v equal 0. If the question say determine whether two vectors are orthogonal, perpendicular, then you remember it will be u dot v equals 0. So if the word parallel is the cross product. If the word orthogonal, all right, it is dot product. It is dot product. Okay, all right. So don't get confused. Okay. Now, if you have the diagram just now, you have this one. Okay, so this is actually, there's another formula for the area that you can find using cross product. Okay, when it comes to vector. Okay, when you are dealing with a vector, all right, definitely there is also actually a diagram, because if you look at this figure 3, okay, you have this figure 3. All right, basically if you have two vectors, okay, actually this is supposed to be vector A here. This is or maybe I put this is u, okay, because I'm looking at this formula. Okay, I'm looking at that formula. So then this is vector v. Okay, so then maybe I'll rewrite this as vector v and then sine theta. Okay, all right. So if you look at this diagram here, all right, this is actually you have these two vector, vector u and vector v. All right, so we can actually extend this and becomes a parallelogram. Okay, become a parallelogram. Okay, and we can also find the height here. Okay, the height of this, all right, parallelogram. Okay, using our trigonometry. All right, to find this length here, this is theta. All right, this is theta. This is vector v. So to find this, okay, so then this is our hypotenuse, right? This is our hypotenuse. This is our opposite. So then by using our trigonometric all right, trigonometry ratio last time. So this height can be written as vector V times sine theta. Now, why is it that we have to put this magnitude? Because the height is actually is the length. Okay, the height is the length. So when it comes to the length or distance, all right, that's why we have to put this magnitude, because we are talking about length. Height is the length. So if you don't put this length here, that means it's actually not logic. Okay, it's illogical. Okay, so that's why the definition is like this. So you have this, okay, sine theta. So that's the height here. Okay, so then based on that, based on here, we can, if we want to find formula area, okay, if you can see down here, area is always base times height, altitude or height, all right. Okay, base is area is actually is for area of a parallelogram. This is area of a parallelogram. Okay, area of, oops, area of parallelogram. Okay, so area of a parallelogram is base times height. Area of a triangle is half times base times height, because last time, remember, we have looked at also this, right, this type last time, that to find area of a triangle is half of the area of a parallelogram. So area of a parallelogram is base times height, or base times altitude. Okay, base times altitude. So in this case, when we talk about base times altitude, okay, now, because we want to compute area, and base, altitude or height, referring to the distance, length, okay, it's a length. So back to this diagram. Okay, if you look at this diagram, okay, so base is given by this vector u here. Okay, base is given by this vector u. So this is the one. Of course, again, you will see it's a magnitude, written in terms of magnitude, because it's a length. Okay, it's a length. So it's the length of vector u, and height of the parallelogram is given as this, magnitude of v times sine theta. So magnitude of v times sine theta. So this is base, and this is height. All right. So then, if you look at this definition, that magnitude of u times magnitude of v times sine theta, that is actually is similar to this. All right, magnitude of u times magnitude of v times sine theta, that is actually equals to magnitude of cross product. Okay, it's magnitude of cross product. So that means this is actually is the same as area of a parallelogram. Okay, that is actually is area of a parallelogram. So that means magnitude of u cross product of u and v, magnitude of u cross v, that is actually is area of a parallelogram. So from here, okay, so that means this is actually is area of a parallelogram. So if we ask you to find area of a triangle, so that means area of a triangle equals to half of magnitude of u cross v. Okay, area of a triangle is half of magnitude of u cross v. Okay, all right. So then we can actually look at this example now. If let's say question asks you to find the area of a parallelogram, okay, area of a parallelogram with two adjacent sides formed by vectors A and vector B, all right. So that means, first of all, when it comes to area of a parallelogram, immediately you remember that that is actually is a magnitude of a cross product. Okay, it's a magnitude of a cross product, which means that if, let's say, this question is about vector A and vector B, that means area of a parallelogram, you know that it will be your magnitude of vector A cross vector B. That is area of a parallelogram. Okay, so which means in this case, you still need to find cross product. First, you have to find what is A cross B first. Okay, so which means, again, same concept earlier. All right, A, Y, J, K for the first row. Second row will be component for vector A. So in this case, vector A is 1, 2, 3. Okay, basically, I'm using the same thing. Vector B is 4, 5, 6. Okay, so A cross B. So if you look at this one just now, we have done this earlier. All right. All right. This type of vector is actually, that type of cross product is actually this one, the earlier example here. This one. Okay. This is the one. I just want to take the answer, and I would just want to continue with the magnitude actually. So this is actually similar, where you have found to be this answer. You will get minus 3i plus 6j minus 3k. Okay, so I'm just going to use that answer. Okay, I hope you all understood how to actually compute this. So from the previous example, okay, what we got actually, we will get this minus 3i plus 6j minus 3k. Okay, all right, this is from the previous example. Okay, so now what you need to do is, because question is asking for area of a parallelogram, so you know the area of a parallelogram is actually is the magnitude of that cross product. So therefore, you just need to find what is the magnitude, or maybe I'll just write area of a parallelogram is equal to magnitude of A cross B, okay, which is in this case, we have found A cross B to be minus 3i plus 6j minus 3k. So that means now you need to continue and compute for the magnitude, okay, which means minus 3 squared plus 6 squared plus minus 3 squared, square root of that. So you use your calculator. All right, 36 plus 9 plus 9. So 36 plus 18, isn't it? So that is square root of 54. Okay, you can just leave your answer like that. No need to change to decimal. Okay, all right. So then you can just say square root of 54 unit square. That's the area. Okay. All right. Okay, so that means area of a parallelogram is just magnitude of the cross product. That's what you need to remember. Okay, area of a parallelogram is just a magnitude of the cross product. So if question asks you for area of a triangle, it will be half of that. Okay, it will be half of the area of a parallelogram. That means it will be half of the magnitude of the cross product. Okay. Okay, so let's look at the example here. This time, find the area. Okay, find the area of a triangle with vertices P, Q, and R. Okay, find the area of the triangle with vertices P, Q, and R. Okay, I know that it's 11 o'clock, but I just want to finish up everything, then only we'll take a break. I hope you all don't mind. Okay, just bear with me. Okay, so let's do this. You want to find the area of a triangle with vertices. So if let's say I just roughly just want to show you. If let's say we want to some sort like sketch this. Okay, so if we want to just sketch this. Okay, X, Y, and Z. Okay. All right. So P is 1 minus 1, 0. So assuming that 1, okay, 1 minus 1, 0. So let's say this is P. That's the P. Okay, Q, let's say Q is 2, 1 minus 1. So Q, 2. So let's say 1, 2, 2, and then 1, go to the right, 1 unit, and then minus 1, so going down. So that is, let's say, that assuming that that is Q. All right. And then R from 0, R is minus 1, go to, all right, opposite, my opposite direction 1. And then 1 unit, go to the right, 1 unit, and then 2 unit up. Okay, assuming that that's the R. Okay, so basically you have this triangle. Okay, so you have this triangle. You have that triangle. Okay. All right. So question asks you to find area of this triangle. Okay. Now, of course, you do not want to use formula that you have learned before, like half times base times height, or what else you have learned? Half AB sine C, something like that. Okay, perhaps you have like this triangle with all these three coordinates, so you might want to use a vector, concept of vector to find area of this triangle. Use vector, okay? Use concept of vector to find area of a triangle. And just now, you know that area of a parallelogram is actually is a magnitude of cross product. So that means if you want to find area of a triangle, it will be half of area of a parallelogram. Okay, you have that. That means it will be your half times magnitude of a cross product. Okay, anything in this case, this is a cross product. Let's say I'll just write like this first. Okay, A cross B. Okay, but you are given this coordinate in terms of PQR. So which means you just need to establish two vectors, all right, in which, all right, you need to do the cross product. You need to find its product by using cross product. Okay, you have actually more than one possibilities, more than one ways in terms of vector. You can say the cross product, your cross product, you can say PQ, all right, PQ cross PR. If I say PQ cross PR means, okay, if let's say I just draw another again here, this is my Q, P, and R. If I say PQ cross PR, that means PQ cross PR. I'm doing like this. Okay, that is PQ cross PR. Or maybe other people would like to have like not this one. Maybe other people would like to have, for example, this is PQR. Maybe you can say QR cross QP. Okay, QR cross QP. It will be like that. Okay, this is PQ cross PR. Okay, or maybe there are other people. Maybe you look at it as like this is PQR. So you can say RP cross RQ. RP cross RQ. Also can. Okay, also can. So you have actually more than one ways to do. Okay, so it doesn't matter. Whichever you do, all right, you will get actually the same answer for the magnitude. Okay, for the magnitude. Okay, all right. So let's just take one. All right, maybe I'll just take this one. Maybe. Okay, PQ cross PR. Okay, PQ cross PR. So which means, all right, which means if I'm saying PQ cross PR, that means I need to find what is my PQ. Okay. I need to establish this correctly. My my vector PQ as well as my vector PR. Okay, so again, back to the component just now. Okay, from coordinate actually. Look at the coordinate carefully. All right, P is 1 minus 1, 0. Q is 2, 1 minus 1. And R is minus 1, 1, 2. So we have to find component for vector PQ first. All right, so the vector PQ. All right, I hope you all are with me. Okay, PQ. So remember, terminal minus initial. So PQ. So that means 2 minus 1. All right, and then 1 minus minus 1. And then minus 1 minus 0. So that is component for vector PQ. Okay, component for vector PR. Okay, so now PR, PR, point P and point R. So again, terminal minus initial, okay, PR. So PR minus 1, minus 1. So minus 2, that is the first component. Second component, 1 minus minus 1. So that is positive 2. And then the last component, 2 minus 0. So that is component for vector PR. Okay? Alright. If there's any question, you just let me know. So I'll just proceed. So once you have found those two vectors, so that means you want to find area of your triangle PQR. It will be your half times area of parallelogram. So area of a parallelogram is a magnitude of a cross product of two vectors. So in this case, it will be magnitude of PQ vector cross with PR. Oops, cross with PR vector. Okay, cross with PR vector. So this is what we want. All right, to find our area of triangle PQR. Okay, so that means now you need to find what is your PQ vector cross with PR vector. So again, IJK for the first row. Second row, it will be component for vector PQ. So vector PQ, 1, 2 minus 1. And then the last row will be component for vector PR. PR is minus 2, 2, 2. So you set up your 3 by 3 determinant. Okay, and then you do like previous example I showed you. Okay, it will be your positive I minus J plus K. Okay, positive I minus J plus K. Alright, so for the I, you cover your I column. So it will be your 2 minus 1, 2, 2. For unit vector J, you cover your J column. So you cover your J column. So that will be 1 minus 1 minus 2, 2. And then for the K, you cover the last column. So it will be 1, 2, minus 2, 2. And then you compute correctly, all right, your 2 by 2 determinant. Okay, all right. So compute correctly your 2 by 2 determinant. So basically it will be your 2 times 2 minus minus 1 times 2. This is for the I. And then for the J, minus. And then for the J, it will be your 1 times 2 minus minus 1 minus 2. This is for the J. Okay, this is for the J. And then plus for the K. All right, it will be your 1 times 2 minus 2 times 2k. Okay, make sure you compute correctly, yeah. Okay, so then, okay, 4 minus 2. So you have your 6, right? 6i, okay, minus, okay, 2, and then you have minus, so it becomes minus. So 2 minus 2. So 2 minus 2, 0, isn't it? Nothing for the j. Never mind, I put the 0. Okay, I just put 0j. Okay, and then plus, and then you have your 2 minus, so plus 4. So then you get your 6k. So basically, you have your 6i minus 0j plus 6k, or you can say 6i plus 6k. Okay, you can write 6i plus 6k. All right, but what I need is now the magnitude. I need to compute. All right, I need to compute this, or I can just straight away, maybe I can just straight away write. Therefore, what I want is actually is the area, okay, is the area of a triangle PQR, which is then half times magnitude of PQ cross PR, which is then half times square root of 6 square plus 6 square. So that means half times 72. You can just leave your answer like this. All right, or if you want to simplify, 72 is actually is 6 2 also can. All right, if you want to simplify, then it is just 3 2. All right, so this is now unit square. So that is the area. Okay, area of a triangle. Okay, any question? Okay, I have one last one. Okay, before we take a break. Okay, I still have one last one. Okay, because this is three-dimensional space. So when it comes to three-dimensional space, all right, you can also talk about volume. Okay, finding volume, because volume is for three-dimensional geometric. All right, this is for three-dimensional coordinate system. Okay, is a geometric in terms of three-dimensional space. You can find a volume. Okay, two-dimensional, all right, we find area if it's three-dimensional, because then when we talk about cross product, it is actually becomes a three-dimensional. Okay, it is a three-dimensional diagram. You have actually this diagram here for your three vectors. The three vectors means is vector u, vector v, and vector cross product. That cross product is, all right, is actually for this diagram, it is represented by w here. W here is actually is this cross product here. Okay, it's a cross product. So you have your vector u, vector v. All right, sorry, vector w is another one, which is actually talking about the three non-coplanar vectors. So this is actually is the cross product here. Okay, for u and v. Okay, but whatever it is, all right, perhaps what you want is actually is just this one, that the formula for to find volume. Okay, to find volume from the three, they call it non-coplanar vectors. Non-coplanar vectors mean the three vectors which are not on the same direction. Okay, not in the same direction. Okay, so if you have vector with like this, so you can actually draw some sort like a cube, like a cube or cuboid. Okay, which is a three-dimensional geometric illustration from this diagram. So you can find a volume, all right, for this what we call a cube or cuboid. Okay, from the three vectors. So they call it what they call using the formula of scalar triple product, they call it scalar triple product. Scalar triple product means is vector u dot with vector v cross w. That is what they call scalar triple product. Now scalar triple product means you have triple means u v w, three vectors. Scalar because you have the dot here, so that means at the end of the day, because you want to find volume, it has to be a number. Okay, it has to be a number. Okay, so when it is a number, so that's why you have a dot here. So when it is a number, you have to actually settle the cross product first, because u is a vector. You can only dot with another vector. So a vector is actually v cross w is actually gives you a vector. So when you have a vector, another vector, you can dot. So what you have is actually is a number. Now this magnitude here, this magnitude also refers as like, or as like an absolute value as well. Okay, you can regard this magnitude as like your absolute value. That means inside, definitely, because of the dot, definitely you will get a number. You will get a number. Okay, when you dot this vector u with another vector from this cross product, you will get a number. But your number can be negative in this case. Okay, your number inside here, scalar triple product, can be negative. But because of this magnitude here, straight away it becomes like your absolute value. Absolute value, if you have a negative number inside, it becomes positive. Okay, because what we want is actually is a volume. So definitely it has to be positive number. Okay, so this symbol can also be regarded as like absolute value symbol as well. Okay, all right. So this is our last example. Okay, our last example before the break. So this is where we talk about using scalar triple product. Okay, you see the word parallelopipe. Parallelopipe is because of it's a three-dimensional. Two-dimensional, we call it parallelogram. Okay, parallelogram is two-dimensional. Three-dimensional, we call it parallelopipe. So that's why if it's a two-dimensional parallelogram, we find area. Area is only for two-dimensional space. But when it comes to three-dimensional space, we can find volume. Okay, so when we say find volume, it has to be volume of a parallelopipe. So it doesn't make sense if you come across find volume of a parallelogram. It doesn't make sense in mathematics, because parallelogram refers to two-dimensional. Volume is for three-dimensional. So if it's a volume, volume of parallelopipe. If it is area, area of a parallelogram. Okay, all right. Okay, it's the same like if it is two-dimensional, we call it square, right? If it's a three-dimensional, it becomes a cuboid. Okay, something like that, right? All right, okay. So how to find volume? Volume is actually, again, is this one. Okay, all right. It's what we call using scalar triple product. And actually, if you are given UVW, it doesn't matter. It doesn't matter which one which. In other words, the volume is actually, the formula volume is given as like this, a magnitude of U dot V cross W. But if we want to say that this is V dot U cross W, also can. Or you want to say this is W dot U cross V, also can. So it doesn't matter which one which. Because these three vectors are, they call it non-coplanar. They are not in the same direction in space. Okay, so it doesn't matter which one which. It is the same concept like just now I mentioned about this. Right, this one just now. It depends on how you see it. Either you look at like this, or you can look at this, or like this. It will give you the same answer. Okay, so same with volume as well. Okay, so it doesn't matter which one which, as long as definitely question will give you like three vectors, and these three vectors are, they call it non-coplanar vectors. Okay, they are not parallel, they are all different direction. Okay, but of course the initial point are the same. Okay, they are all coincide, initial point all coincide. Okay, so perhaps we can just look at the first one only, like this maybe. Okay, so what you want is you need to find, you need to find, definitely you have to find your cross product first. You have to find this one first, then only at the end you can dot. Okay, because dot means that later on you will get a number. Okay, and you can only dot if you have two vectors, and this will give you also the product is a vector. So first you find your, what is your V cross W. So this is what you want to find first. Okay, so again, your IJK. All right, and then V component. Okay, 4, 5, 6. W, 7I plus 8J, no K. So that means 780. All right, so then it will be, okay, maybe I'll straight away write this, if you don't mind. For I, you cover the column I, so it will be your 5, 6, 8, 0. This is positive I. Minus, okay, then you cover your J column, 4, 6, 7, 0, K, sorry, J. And then plus for K, you cover the last column, so it will be 4, 5, 7, 8. All right, so K. Okay, maybe we can straight away compute this, okay, if you can all follow me for the I. So you start with the multiplying main diagonal, 5 times 0, so 0. And then minus, you still have minus 0 and then minus. So don't forget, as I mentioned, the tendency of making mistake is there if you're not careful, okay? All right, so if I make mistake, you just let me know also. Okay, so main diagonal, 5 times 0, 0, and then minus, oops. Okay, and then minus, okay, then 8 times 6, so that is 48. So that is for the I. Minus, okay, for J, okay, main diagonal also 4 times 0, 0. And then minus, okay, so you have that minus. Put a bracket so that it will be correct plus or minus later on. Okay, so then 7 times 6. That is for the J. So you see, there's a positive there later on for the J. Okay, plus. All right, and then again, main diagonal 4 times 8, 32. Minus, okay, 7 times 5, 35. Okay, 32 minus 35. There's a minus there, isn't it? So that is minus 32 minus 35, so minus 3K. So which means it is your minus 48 plus 42 positive and then minus 3. Okay, if there's a mistake, you let me know if I make a mistake. Okay, so that is your V cross W vector. Then finally, what you want is actually is the U, oops. Okay, so it will be U dot V cross W. Okay, which means it will be your U vector is 1, 2, 3 from the question. Dot with, okay, the one that we have found from our cross product, minus 48, 42, and minus 3. Okay. All right. So dot 1 times minus 48 plus 2 times 42. Okay, plus 3 times minus 3. What do you get? Okay, use calculator. What do you get? Okay, I straight away get this is positive 27. So you see it's a number. Okay. Now, sometimes there's a question whereby, okay, all right. You can just, this is actually is the same, You just ignore that. Okay, sometimes you may get negative, negative answer. You can get negative here, You can get negative because this is dot product. So you can get negative. That's why you have that absolute value comes in. Okay, so your final answer, you conclude, therefore, the volume, okay, of your parallelopipe is your magnitude of your U dot V cross W. So in this case, what it have is just 27, which is 1027 unit cube. So sometimes you give, as I mentioned, you got negative. Okay, when you got negative, For example, you compute suddenly you get u dot v cross w, you get negative 20, for example. So that's why then you can say therefore volume equals to, all right, negative 20 absolute value. So straight away is 20 unit cube. Okay, so that magnitude symbol can also regard as like your absolute value, because when it comes to volume, it has to be positive number. Okay, for this one, just so happen, it is actually positive 27. Okay, so basically your final exam is until here. So our vector is actually until here. Okay, all right. We take a break for 5 minutes, and then when we come back, I will talk about final exam. Okay, I'll talk about final exam after we take a break. Any question, everyone? Anyone? Can you all follow me? Is it understood? Is it understood? Can you all follow? Yeah, all right, okay. Okay, so we take a break for 5 minutes, and after that, I'll talk more on final exam. So you make sure everybody is there when I talk about final exam, because I'm not going to repeat. Okay, 5 minutes break. All right, okay, is everybody there? Okay, everyone, are you all there?
Yes, madam.
Okay, all right. Okay, for final exam, I think have you all got your exam slip? Do you know when can you get your exam slip? Anybody has gotten their exam slip? Anyone?
SMP.
Yes, madam.
SMP. Does it mention about the link for final exam portal in the slip? Because I'm not sure. I'm not sure.
Got, madam, got.
Okay, got. So that means you know the link for the exam portal. All right. Okay. So if you look at your exam slip, when is our mathematics subject? When is the date?
28.
Yes, 28. Basically, that is our. In fact, that is actually the first paper, isn't it? First paper for first day. All right. First of all,
Next week,
let
madam.
me just. Okay. First of all, let me just remind you again. It will be your paper. Our technical maths will be on the 28th of January. So I think it's just in like 2 weeks time, isn't it? Not only 2 weeks. Okay, 1 week plus. Okay, it will be online. So that means it means that it will be similar to like your test that time, isn't it? It's just that now it's a final exam, so it is not our control. It's actually is the academic units control, BPA. Okay, bahagian pengurusan akademik, okay, BPA. So they are the one that control the system. So that means you need to really follow, all right, like stated in your SMP, in your slip. I think they mentioned about the venue, etc., isn't it? Okay. All right. So I will actually we are going to put this also this instruction, okay, in Ulearn, okay, later. Okay, I will put this one also in Ulearn, because I need to also upload into the Ulearn the cover page. Okay, the cover page. This is the cover page of the final exam. Okay, this is the cover page. Again, it is similar to like your test, your assignment previously, where you need to attach your cover page. So it is a must, It is a must. So it is a must that you attach this cover page. And for this cover page, all right, it is, make sure you write down your name here. Okay, name is written. All right, your metric number is written. Make sure you circle. You are which program? You are BEEEE. So circle your BEEE there. All right. And if you are section 1.1/2, circle that as well. All right. And then of course you write down my name here. Okay. In fact, there are all these names, okay, written here. Lecturers, all lecturers. So if you do not know which one is me, then that is so sad, isn't it? Okay. So make sure this cover page is attached, all right, when you want to submit. And then make sure all this, make sure you write, okay, clearly. All right, this is similar like your test last time. And the instruction also is similar to the instruction previously that you have seen. All right, you have this, these are basically the particular. The first part is actually, if you can look at this, the first part is actually is the particular for our. Okay, let me just change this position. Okay. This is actually the particular of your exam. Okay. And then venue, I think they put hall 1. Okay, I think it is stated for you. You have to refer to your slip. Okay. All right. You refer to your slip. Okay. Now this is what you want. Perhaps the format of the final exam. So basically, you have two parts. You have part A and you have part B. Part A, answer all. So it's like compulsory. You got to answer all. So you got 3 questions for part A. Question 1, if you look at this format, it consists of some questions on your chapter 2 plus with chapter 5. Chapter 5 is our current chapter 5, isn't it? Vector, okay, the one that we just finished. Okay, so that is for question 1. Question 2 is actually is from your chapter 4 complex numbers. And then question 3 is from our vector also. Okay. So that means this is one big question here. Okay. If you look at question 1, basically you have some additional vector question. So that means you can roughly think that, perhaps, you can assume like question 1 vector maybe just a simple one perhaps. Okay. Because it's just a small part because you have additional to the chapter 2 questions. Okay, but the one that we can actually ask you more is actually is from the last one here, question 3, because this is like one big question here. Okay. All right. And for the marks, okay, for the marks, it's actually 25 marks each. This is 25 marks each. Okay, 25 marks each. Because then altogether we will make up to 100 marks. Okay, together with your part B, 1 mark. Okay, I mean one question. So basically you are to answer 4 questions only. Okay, so that is for part A. Part B is actually is a choice question. Choice question, answer 1 question only. But both question 4 and 5 basically is from your application of trigonometry. Okay, so, but as I mentioned previously, application of trigonometry, okay, they provide the diagram. So basically, I'm not saying that it is difficult or easy because I haven't seen the question. All right. But all I know is actually the diagram is given. So like I mentioned previously, if it's application of trigonometry, if you are given a diagram, so that means you can just figure out your solution based on that. Make sure you label correctly. If it is not labeled, okay, you label, all right, your diagram correctly, etc. Okay, so your answer will be based on the diagram that you have. Okay, all right. You make sure beforehand, you make sure you have your calculator, your stationery, and your answer sheets ready beforehand. Okay, don't like at that point of time only you are trying to find, pencil, pen, calculator or whatnot. Okay, and make sure you also have enough answer sheets. All right, roughly make sure you have with you. Don't like until in the middle, after 1 hour, then suddenly not enough paper, so you are trying to search for it. No, time is actually very precious during exam, already, like your test last time, isn't it? Okay, so time is very precious, so make sure everything is actually is handy, is all within your reach. Okay, so you can straight away, like if you need to compute, calculator. All right, pen, pencil is there. Okay, and papers also. Make sure you have enough papers. Okay, and not only that, you have your this one also, books, because appendix formula is not given. There's no appendix. All right, no appendix is given. All right, since this is an open book exam, because all right, because it's online. Okay, online. So even if I said it's a closed book, how do I know whether people look at it or not? So that's why then we all decided, we all agreed that, yeah, why not just tell students it's an open book exam, so that if people want to search for answer, by all means do it. Okay, all right. But make sure that you answer within specified time. You only have 2.5 hours. Exam is 2 hours and 30 minutes. Okay, 2 hours 30 minutes. All right. So make sure that you have your like last 30 minutes is for the uploading. Okay, so this time you have to answer within 2.5 hours. All right, and then last 30 minutes is for you to upload. So I would suggest that by the time it's like 11:30, you stop, then straight away you upload. Okay, straight away you upload, because you will remember, you have to remember, during that time there'll be like not only you who actually use the portal. Okay, it will be also other students. Okay, not to mention that for technical maths only, we have how many hundreds of students taking, for both faculty, electrical, electronic, as well as the manufacturing. All right, manufacturing and mechanical. Okay, so you have like so many programs taking this subject, together with other subject who are actually also taking exam parallel with your time. So there will be many students. So you can think of, like if you are doing it last minute, maybe the system will be very slow. So by the time, like 12 o'clock, definitely if you don't upload by then, system will straight away disable the lock. All right, so by then if you don't submit, that means you don't attempt your final exam. And it is beyond our control now, because as I mentioned, final exam is administered by by BPA, by our university academic unit, not us. Okay, so you must make sure that you really follow the time. All right, by 11:30 stop writing, straight away upload. Okay, and don't forget to attach your cover page. All right, cover page must be attached. Cover page must be attached. And then for each papers also, for each paper, this is final exam, so you must write your name and your matric number. Okay, you must write. Okay, so back to here, you can actually look at your textbook. It's open book, so that means you can you can open your book in a way to find formula. Okay, I would suggest, my suggestion is actually, remember last time there's an appendix also, appendix to the previous final exam in your module. Okay, in your textbook. So I think you can actually use that. You can use that. Okay, so, because then that is actually very handy. Okay, so you make sure you some sort like put a tag or whatever, so that you can easily open. All right, okay, that particular page. Okay, put a tag whatever. Okay, so that you can easily open that particular page. Okay, when you won't need to refer. All right, and make sure again, like similar to that test also. All right, as well as assignment, make sure your writing is legible. Make sure we can read. Okay, we can read your handwriting. All right. And again, answer to a new question should start on a new page. Pencil is not allowed, similar to your test previously. Make sure your name and student metric number are written on every page of your solution papers. All right. Okay, so make sure you do that this time, final exam. Okay, and it is your responsibility to ensure that you submit your solution by uploading it into the online exam portal before 12 p.m. Okay, because then after that, any late submission will not be considered and entertained. Okay, I think they will straight away lock the system if I'm not mistaken. Okay, so you need to submit before 12, not before 11:30, before 12. Your exam, you can write your answer, do your solution for the final exam until 11:30, from 9 o'clock to 11:30. So by then 11:30, alright, you must stop and then you need to upload. Okay, alright. Again, this is another important thing. Renaming the file. Renaming the file. Okay, you must follow this. Again, I do not know how many times we should tell you, but until today also, as even assignment also, people don't actually name their file according to what we want. Still got like name of the file, assignment 3. That's it, like that. Okay, even though we say that you put like A3 underscore BEEE underscore 1 underscore or 1 or 2, depend on your section, underscore name. But people still like assignment 3, like that only. And then name. Okay, name, at least if there's a name, then it's easy for me to see. But it's like assignment 3, then I have to open up and see who are these people. Okay, so make sure this time for final exam you follow. FE means final exam, then followed by your program, and then your section, and then your name. Okay, and then your name. And it has to be in PDF, of course. Okay, not in Words document or whatever. Okay, it has to be in PDF. So again, for the last time, I hope that this time everybody follow this correctly. Okay, for the last time. Because final exam is very important. We are given only specified time to mark. So we have to be very fast in marking for final exam. If it is like assignment, test, we have our own time. Okay, so we can have like 3 weeks to mark, 4 weeks, up to us. But final exam, we are given the timing, all right, from the academic unit, university academic unit, from BPA. So if you follow correctly with this one, okay, naming of your file, then it will be faster on our part, on our side, on my part, all right, because everything is online. We are marking online, so it's all soft copy. So soft copy is not easy. If it is a hard copy like answer script, hard copy, physical answer script is easy. It can be faster, especially key in marks especially. But when it comes to like soft copy, it's actually certain thing can actually slow us down. Okay, because if this one you don't follow, it can actually slow us down, because we have to look at your name. We have to find, after we mark so many, like I have hundreds over, so I have to make sure that this one belongs to what. So if you're naming or the file, you follow this, it will be very fast for me, because I have to make sure also that everybody attempted the final exam. I do not want to, at the end of the day, after I have key in, then only I see that I have a missing script. I do not want to do that. I do not want to have such happening, which I had for the test last time, for your information. Suddenly at the end of the day, after I finish key in, and then suddenly there's one, like one name where I don't have a script. I have like a missing script at the end. So I do not want to have this happening also during the final exam, because final exam is like very strict matters. So please, again for the last time, follow the renaming of the file. Okay, you can upload unlimited number of files, but the maximum size for each file is only 10 megabyte. Which means that in case some people use a lot of papers, but I'm not so sure how many. I think it is still actually like I think if you combine everything in PDF, still maybe the size is still small, isn't it? Okay, but this one I think coordinator just put, okay, they said that you can upload unlimited number of files, but maximum size each file is only 10 megabyte. I do not know lah. Maybe just in case suddenly some people use so many pages, so many answer sheets, and then suddenly you cannot upload due to maybe more than 10 megabyte. Your file, your size is actually more than that. So then it means that you got to separate. Alright, first few pages maybe as one PDF. Second, another one, another PDF. like that. Then you can upload twice. You can do that. That's why they say upload unlimited numbers, because this time we do not want to limit to just one time. Okay, in case people use more, I mean too many pages, too many answer sheets. Okay, so this is just to be on our safe side actually. So if you happen like using a lot of papers and then suddenly it is like the size is more than 10 megabytes, so you just need to separate it. Okay, so upload half. Okay, half pages, half at a time, like that. Okay, so you can actually do that. Okay, again, do not forget to attach final cover page. So final exam cover page is actually a must. Okay, the one that I showed you just now. So I'm going to actually upload this cover page hopefully by tomorrow. Okay, by tomorrow perhaps. All right, as well as this instruction as well. Okay, so again, this one just to make sure that you write your name, metric number, program, okay, etc. Some marks will be deducted for the following reason: cover page, not attached document, not in PDF. Okay, but so far, just to be honest to you, like test people don't put cover page, we do not actually deduct. Okay, because the result was so bad, was so like result was not that good for the test, so we don't have the heart to actually deduct marks for you when you don't have actually cover page. But we do have, people do not follow this instruction. There's no cover page. All right, for the test. All right, the one that put cover page at the end, I still can accept as long as there's a cover page. All right, but those who did not at all attach, that I do not understand. Okay, because we have actually mentioned this many times, but people do not want to follow. Okay, but this time for final exam, please make sure you attach your cover page. Okay, because as I mentioned previously, that all these scripts is all ISO file. This is all ISO document. So at the end of the day, it will get audited. It will get audited by when those panel came. All right, they come and audit. They will actually look at the answer script, all the documents. Okay, all the documents. So that's why you must have a this cover page. So that is much easier. Okay, it look like very consistent. Everybody have this cover page, and then there's a mark written outside, things like that. So it looks actually nice. So that actually gives some plus point when they come and audit actually. Okay, all right, so basically those are the about final exam, especially the format lah. This one, I think this one is also the most important thing that you need to know. Okay, so that you can actually prepare mentally. Yeah, okay. You have actually many people may ask about past year's exam questions, but as I mentioned in your module, your last pages, there are many past years. There are many past years in your module. Okay, it's just that whether you want to do it or not, because there's a lot. Okay, or whether you can do all of them or not. Okay, so that is a different matter. But those are actually past years where the authors actually have put in, okay, at the very last page, in your module. Okay, so you have, they call it like review exercise 1, review exercise 2, until review exercise 7, and that's also answer for each question. All right, and also there's an appendix also, as I mentioned, there's an appendix also in the book, so perhaps that appendix you can actually use it, all right, when you answer our final exam. Okay, you can refer to that appendix so that it will be much easier, because it's all they put almost all formulas there. Okay, so that you don't have to like search, all right, in your book, this formula in which page, what page, so you just refer to the appendix given, all right, at the last page, which is on page 271, in your module or in your textbook. Okay, so you can actually try this all this review exercise during your study week. Okay, during your study week you can try them all. Okay, and then for this Wednesday, for our tutorial this Wednesday, okay, we have to like some sort like do like marathon. We have to like go through all question quickly for back test. So maybe for Wednesday session, okay, for Wednesday session, make sure make sure if you can actually you can, if you, of course, if you have the time and you can do all question, that is good. But if you don't have time to answer all, okay, maybe during that time we can actually go through quickly like last time. Okay, and if there's any like question which you think that you do not understand, that needs clarification, then I will show you. Or else I would just like assume maybe this question you can do, this question you can do, you know. Because I think vectors also something like a complex number where you can actually do this. Okay, you can compute this, you can do this. It's just that certain question it can be like very long. Okay, in terms of solution it can be lengthy. Okay, so you have like you have to compute so many things. Perhaps it will be like that. Okay, for vectors, but it is not as difficult as if you compare to your like application of Trigo, because the application of Trigo, okay, because of all those statements, you know, words, and you have to find out, you know, this is what this statement is about what, and then you got to translate from the words, all right, to mathematical equation. So then perhaps that one actually require more time. You have to read, you know, the like application you got to read like maybe more than once or more than twice. Okay, the question. But I think like complex number and vectors is just a matter of computation, is a calculation. It can be quite lengthy depending on the question. Okay, depending on the question. Okay, so basically I think chapter 5 vectors also is actually not really that difficult if you have understood lah. Okay, during the lesson you have understood, like just now the one that we talk about cross product, you know, finding area of a triangle, finding area of a parallelogram, volume of parallelopipe, you know, or even find cross product, find dot product. So that is actually not really that difficult if you understand how to do it. Okay, it's just a matter of not making careless mistake in calculation. That is the most important part. Okay, don't make any like mistake in plus minus sign, things like that. So you have to be very careful in computation. So basically for, I think complex number and vectors are just like that. Okay, all right, okay, I think that's about all for today. Okay, maybe you can start looking at questions in textbook, okay, for vectors. All right, all questions, and then we will discuss that in our last session on Wednesday morning. Okay, I hope that I will have many participants on Wednesday, because that is our last day of instruction, last day of class, okay, for this semester. Okay, all right, anybody got any question?
All clear, madam.
Okay, good. All right, so make sure everybody start doing the revision now. Okay, start doing the revision. I would suggest you discuss among each other. If you have any question, you discuss among each other. Okay, even though I know that it's very hard, because every in terms of location wise, okay, but nowadays I think distance is not a matter, isn't it? Okay, you have your WhatsApp, you know, you have your this online whatever. Okay, so you can actually discuss now that you have your group members, okay, for assignment, etc. So you can actually discuss, discuss among you all. Maybe you do certain question, all right, you don't understand, you discuss among you all. Okay, because if it is like normal physical, right, face to face, when people are in on campus, okay, that's what actually students do. Normally they will sit down together and discuss. So you might want to try to do that. Okay, but the most important is make sure you start doing the revision, okay, for the final exam. All right, and make sure you have understood the lesson, okay, the one that I have taught you. And then I will also upload the recorded session today into the ulearn. In fact, I think I'm going to also upload the solution for assignment 2. Okay, assignment 3 I am still in the midst of marking, but assignment 2 I've already finished marking, so I'm going to upload also solution for assignment 2. Okay, for you to refer to. Okay, since you have a copy of your assignment 2, so you can actually compare, all right, or you can mark your own assignment 2 later on. So I'm going to upload that. I'm going to upload also the recorded session. Now, for last week, week 14, I've also uploaded the recorded session for lecture as well as tutorial. But I uploaded for another group, BEET group. But we are talking about the same thing, okay? We were talking about the same thing last week, so you can also refer to that particular video. I did not actually put up your groups one because somehow I do not know why. Sometimes, you know, I think it's something about the Webex, or I think maybe the internet connection. I do not know why, but sometimes for the first 1 hour, um, it doesn't actually I mean the screen, it doesn't capture the screen. It doesn't capture my slide. So when I look back, what I have is all your your names, you know, the front page of the tiles. Remember the Webex, get the names, you know. It's not my slide, the screen. It doesn't capture my teaching slide. Okay, so that's why I did not actually upload your session. But somehow the BEET group on Tuesday, it was the recorded session. When I look back, it's all like smooth. Okay, it shows my slide from the beginning until the end. So that's why I upload, okay, the BEET session. Somehow I noticed, I do not know why, like if it's like Wednesday, Monday 10 o'clock, sometimes even Wednesday also, I have a problem. When I look back the Webex, it doesn't capture my slide. I do not know why. Sometimes it captures after like 1 hour only I can see. Right? But for the BET group, so far it's like actually like no problem. So that's why if you notice in the ULEN, I always actually upload the BET session. But sometimes there are your session also that I uploaded. Okay. But anyway, as I said, either group is actually, we are talking about the same thing. Okay, it's the same content actually. Okay. All right. Okay. So if there's no question, I think then I will meet you again for the last time on Wednesday morning. Is that okay?
Okay, madam.
Okay, madam.
All right. Okay. So we'll meet on Wednesday, Inshallah, this Wednesday. Okay. Thank you very much for listening.
Okay, thank you, madam.
All right, guys.
Madam.
Assalamualaikum.
Thank you, madam.
Madam.
All right.
Thank you, madam.
Okay. Welcome.
Okay, madam. See you Wednesday, madam.
Okay. Thank you.